This last section of notes is on blood typing, and blood typing is another example of codominance. So this is where we don't really have one blood type dominating the other one. Instead, usually both alleles would be present, and so we'd get almost more of that spotting effect that happens. So you have 4 different blood types. We have type A, B, AB, and O. So if somebody's type A, they could be homozygous for that type, or they could be heterozygous. So we use I's when we're doing blood typing, and then we superscript whatever blood type that they are. Okay? So type B can be homozygous, or they can be heterozygous. To be type AB, you have to have both the A and the B allele, so that's the only genotype that they can have. And for type O, it's completely recessive, so they have to have the 2 little i's. And that's the only genotype that they can be. But A and B up here, like I said, they can be homozygous or heterozygous. So if they're heterozygous, they're just carrying that recessive O allele, which is that little I. So somebody who is a universal donor, they can donate blood to absolutely anybody. So this is usually type O blood. It does get a little bit tricky when we start talking about those Rh factors, which are the positives and negatives on blood. But for this class, you really don't need to know those. So just remember that type O, because it's recessive, they can kind of give it to anybody. The universal acceptor can receive blood from anybody. So this is type AB blood. So they can get A, they can get B, they can get AB, and they can get O. Okay, this type O he can give to anybody, but unfortunately he can only receive type O blood. And AB can only give to somebody else who's AB, so it's a little bit tricky. So we're going to practice some blood typing. What we want you to do is cross a homozygous type A male with a heterozygous type B female. So again, we've got the genotypes listed down below. So all you have to do is set up your Punnett square. So homozygous type A male. So if he's type A, and it's homozygous, it's got to have 2 of the capital alleles. And a heterozygous type B female. So she's got type B, but she's heterozygous, so she's got to have that little recessive allele. So if you fill in the chart here, that person can be type AB blood. This child would be type A blood. This child would be AB blood. And this one would be type A. So we only have 2 possibilities for blood types here, either AB or simply A. And that's all we can have for this particular example. All right, so then the next one says, could a type A mother and a type B father have a child with type O blood? So what do we think? The answer is actually yes, they absolutely can. Okay, so if mom is type A, we know dad is type B, they both have to have that for sure. The only way to get type O blood, though, is if they're both carrying that little recessive allele. So right down here is where that recessive allele would pop up. That's type O blood. Okay, not here because this is AB, not here because that would be type B, and not here because that's type A, but right here, that's where we get that type O blood. So the answer is yes, as long as they're carrying that recessive allele. And we'll get some more practice with blood typing in the classroom and on some worksheets. So we'll get some more practice using these superscripts and these letter I's. And that's it for the notes.